Hey guys, Ishan here. Today we're going to be talking about combination of events. I'll go ahead and share my screen. Okay, you can see it. So suppose that there are events E and F, all represent E as in red and F in blue, where the probability of E is 0.8 and the probability of F is 0.6. So we want to show that the probability of E union F is going to be at least 0.8. And hopefully this makes some intuitive sense because let's say that this is, let's say that the red represents the probability of E happening. And as you can see, it covers 80%. And even if F is completely a subset of E, so like over here, we can see that the probability of E union F is still going to be at least 80%, which is the original probability of E. So if F is, if there's no extra that F is providing, then we could say that the probability of E union F is at least 80% or 0.8. And as we know, it also has to be less than or equal to 1, just because you can't have an over 100% probability or over 1 probability of any event occurring. So what about the probability of E intersect F? Well, that's a bit more interesting. So let's go through our example here again. And let's draw out E. So that's again it's gonna be around 80%. So let's say that this is 80%. And even if F is as far removed from E as possible, so let's say there's still going to be some overlap, because remember, the probability of E and the probability of F, overall, they can't stretch beyond the sample space. So what does this have to be? This overlap at a minimum is what we're trying to figure out. And so we could write that as the probability of E intersect F. And I'm going to say that this is going to be greater than or equal to 0.4. Now, how can we represent that slightly more mathematically? Well, remember that the probability of E intersect F is equal to the probability of E plus the probability of F minus the probability of E union F. And so we know that the probability of E is 0.8 and the probability of F is going to be is 0.6. Now, what about this probability of E union F? Well, we know that at its peak, again, it can't be any more than 1. So we could say that this is going to be, we can say that this is going to be greater than or equal to the peak of probability of E union F. And this means that the probability of E union F or E intersect F is going to be at least 0.8 plus 0.6 minus 1, which just gives us 0.4. So we're saying that this part, their intersection, has to be at least 0.4, which makes sense because, again, you can kind of think of it as oversized jigsaw puzzles. And so we have E, which is representing 80% of our total space, and F representing 60% of our total space. There's no way that there's not going to be overlap. And this overlap or their intersection is going to be at least 0.4. Hope that helps. See ya, guys.